Hello, everybody, and welcome to the HCD VidCast, episode 17 of our Curious Conversations. Today, we are talking about what is known as the gold standard of psychophysiological measures. That's a bit of a mouthful there, but we're going to break it down for you. As always, in our conversations today, my name is Michelle Niedziela. I'm VP of Research and Innovation at HCD. And I'm joined here today by Kathryn Ambroze. Kathryn?
Hi, everyone. Yep, I'm Kathryn Ambroze, the Manager of Behavioral and Marketing Sciences. As always, we are thrilled to welcome our returning friends back. And if you're new here, we're happy to have you. And I'm going to let Michelle just hop right into who HCD is.
A little bit about HCD. We are a research house providing a variety of different approaches for looking at the consumer experience, the holistic consumer experience, using neuroscience, psychology, and traditional market research tools to really look at how consumers interact with the world around them. We do this in the early stages of exploration, all the way through the later stages of validation, looking across product development into marketing. Our approaches can be done online or in person and have been done globally. So without further ado, I'm going to jump right into our conversation today, which is about some of the tools that we use. There's a lot of tools out there, right, that use neuroscience. So when I said neuroscience as being one of the sort of bucket of tools that we reach from, the bucket's pretty large. There's a lot of tools that you can use. As you can see here on the screen are some of the most popular ones, and by no means is it exhaustive. There's lots of different things you can do. But you can see here are a lot of different tools. The one we're going to be talking about today is on the very left side, the combination of facial EMG with HRV and GSR, which we will go forth and explain in a little bit. But there's these other tools, eye tracking, EEG, facial coding, fMRI, implicit association. All these sort of things are things that anyone can actually do. You don't have to have a special license or degree. You just have to be willing to pay for it. And we also like to mention you get what you pay for, right? So there's two different types of EEG that you can see here. One, obviously a lot more complicated than the other. But, anybody can buy these things. And so we think it's really important to sort of establish what these different tools are. The one we're going to talk about today, again on that far left, is called the gold standard, and there's good reason for that. And that's because if you look at all these different measures, EEG is measuring activity in the brain, but it's not a direct measure of what's really going on. You're looking at electrical activity across the scalp. So it's not exactly what's going on inside the brain. You sort of have to infer by location and timing and what sort of, you've done experimentally. fMRI, again, there's a lot of other things that could be interpreted from the data. What makes something a gold standard in this case is that it's very reliable. And it has a lot of construct validity. So it's measuring what it says it's measuring. So let's jump right in and talk about what this psychophysiological tool is. So there's a difference, right, between psychophysiology and what is commonly called biometrics, although they're kind of interchangeable to some degree, right?
Absolutely. And so it's really, the big difference here is that you want to consider that psychophysiological tools they are within the broader umbrella of the idea of biometrics, and psychophysiology.
Literally, biometrics is measuring the biology, right?
Exactly.
Like it could be anything.
And just like if you broke down the word psychophysiological, you're using the psychology aspects of things as well as the physiological aspects of things to get a broader understanding of what the body is.
It's the physiological side of psychology.
Yes, exactly. So it's, we're using these tools to help understand actionable results. And if you're looking at the example that in the pictures underneath, you can say when a physician is taking your heart rate, those measures are being analyzed very differently than when a market research group collects the same types of information. So the application of biometrics within the context of consumer science has really strong connections to psychology, which is, again, why we say psychophysiological measures.
Yeah. So it's the psychology part that really differentiates it, because all of these could be measuring heart rate, right? But when we are using heart rate in the consumer realm, we're not just trying to measure like literally just the rate of your heart beating. It's to infer some sort of psychological impact of that. Like, are you paying attention? Are you taking in new information?
Absolutely. So it's really that differentiating factor is that it involves the interaction of the body and mental processes.
So one of the main reasons we call these the gold standard is because they are very reliable, right? So physiological measures, you're directly measuring the physiology, and you can measure it over and over again and get very reliable results. Now, the other side of that, to make it truly the gold standard, is that it's got strong constructability, right? So when we use heart rate, for example, to measure something like taking in new information or paying attention, that's because there's a wealth of academic research out there that has directly correlated changes in this physiological state with that inference, right?
Exactly. And small plug, if anybody's interested in them, we'd be more than happy to share.
Yes, there's tons of research out there that we're more than happy to direct you to, or to show of our own or someone else's. But that's really the value in calling something the gold standard. It's accepted as being a gold standard because it is such a strong and reliable measure.
Right.
So let's talk about these a little bit further. The data, right? It depends obviously on how the quality of the tool you're using, but this is what it typically looks like, right?
Exactly. So this is this is what the output would look like typically from the side for the researchers, and you're basically, when you're using these tools, it's the process of trying to understand the physiological responses, like changes in heart rate, to see how the individual or the participant is really responding to that stimuli. So
absolutely. And these are the three, the gold standard: the heart rate, the skin conductance, and the facial EMG. Those three make up the gold standard.
Yeah, and I do want to mention that, just as a reminder, this is really common peripheral nervous system measures. So these three, the gold standard focuses on the peripheral nervous system. Just a little side note, the peripheral nervous system is really any nerves or ganglia outside of the brain and spinal cord. So this is still considered consumer neuroscience. Neuroscience is not just the brain. It encompasses the whole body. And that's really seen clearly here through the use of the gold standard.
And there is a wealth of information here, because you're looking at, second by second, or even less than that, finer tooth comb than that, where you can see changes. So for example, towards the bottom of the screen with the facial EMG, you can see that something was happening a little early on in this experience, right? Now it could very well be that the person, was making some sort of facial movement, eye blinking, or whatever it might be. But you can start to pair these things with whatever the person is experiencing, something on a screen, or that they were smelling something, or that they tasted something, or that a sound happened. You can pair this in the moment to see what their reaction was.
Right.
So let's dive right into some of these measures. Now we're going to talk about heart rate. So what do we mean by heart rate? Why is it important?
So
go ahead.
Yeah, so heart rate, it's really the focus of attention, and it's the level of focus respondents are giving to a stimulus, essentially. And it's collected through, so we have here, it shows that it's heart rate variability versus heart rate. Can you kind of break down what those differences are? Because they can be a little confusing.
Right. So heart rate is really just measuring the beats per minute. Right? Mm-hmm. So in a minute, how many times did your heart actually beat? That's your heart rate. Heart rate variability is a little bit different, right? So it's looking at how many changes there were between the times of the heartbeats within that time frame. So you're looking at the variability across a certain amount of time. So we wouldn't do that within a minute. It wouldn't, we'd actually look at more longer. So you can get a better understanding of the variability that can happen over, say, 5 minutes. So if your heart rate is more variable across, say 5 minutes, then it could be that, there was a lot of changes in the time between the beats, if that makes sense.
Okay, so those behavioral changes include what types of things? Something like increased social skills or self-control or coping mechanisms. All of those things are actually associated with that variability. So it's that HRV is what's associated with that. It's that, your general health is frequently associated with
really good measure of, cognition or relaxation. Those sort of things have been strongly associated with changes in heart rate variability in particular.
Interesting. And then just to touch upon this too, so what you're seeing on your right is our personal setup for it. We tend to use ECG, which is the electrocardiogram, and that
what you're probably more used to getting when you're in the hospital, right? So it's a high grade electrode.
Yes, exactly. So there's actually 3 disposable ECG electrodes that are used, that are highlighted in that picture with those blue circles. And basically the electrode placements can be changed if based on, an experiment's needs, maybe if the subject needs to use their arms or something like that. It can vary, but basically the reason we use ECG versus PPG is because the ECG is able to capture signals by placing those two electrodes on the skin to get the patterns that are occurring in the autonomic system. Mm-hmm. Whereas PPG is more of this technique where there's
using light.
Yes, exactly. So it's recording this blood flow through the near infrared or green LED lights, like you had mentioned. So,
and it's most often found in some of your smartwatches, right?
Exactly. So something like a Fitbit or an Apple Watch. What that technology is doing is that if light is absorbed, there is an increase in blood flow. And that's how they're able to see peaks that are created to represent heart rate. But
this can be really problematic depending on the type of information you're looking for. So PPG is really great for heart rate, right? Mm-hmm. But not so reliable when it comes to heart rate variability.
Exactly. And there's a lot of cases where there's data loss and accuracy problems with something like a wearable that's using PPG. And they're great for certain types of tests, but you don't want to rely too heavily on them because sometimes they can overpromise.
Yeah, so sometimes PPG can be more reliable over a longer period of time because there's more data, right? Mm-hmm. But not so good when you're looking at in the moment research, right? So if you're looking at short exposures to things like ads or shelves or products or whatever it might be, you really want that wealth of data that you're going to get from ECG over PPG. So let's move on to the next piece of the gold standard, which is looking at facial EMG. So explain that, Kathryn.
Sure. So facial EMG is facial electromyography, which is always such a fun word to say when it rolls off the tongue. But
it looks very intimidating when you first see it.
It does. And you know, as a technician, you can make a lot of jokes about it with people to help them ease their nerves a little bit. A lot of times when
pun intended.
Yeah. Yeah, sure. Let's go. I did intend that. So basically, the facial electromyography, it measures the electrical activities of individual muscle contractions. And that is done specifically in the face at certain areas to measure. Specific
to emotion.
Yeah, so it's to measure the variance of the facial expressions that are associated with the internal emotions.
Yeah, so those 3 groups are the corrugator, the orbicularis, and the zygomaticus. And right. So what do those do?
So let's break it down. So the corrugator muscle it's a small rectangular, I'm pointing as if you can see me.
Let's go with color. The corrugator is the green.
So it's the green.
On the forehead.
Yeah, it's the green on the forehead, and it's located in around the middle of the eyebrows, and that's associated with negative emotions. So
you can imagine you might be furrowing your brow or something like that, right?
Exactly. And frequently that has been, it gets activated when you're exposed to something that might be unpleasant, or maybe you're frowning based on concentration. So it's context dependent, like all of these tools. But for that, it's generally associated with negative emotions.
Mm-hmm.
Whereas,
next up.
Yep. Whereas the positive emotions are seen with the latter two muscle groups, and the zygomatic major, it raises the corners of the mouth when you're smiling. So it's, possibly, and it's interesting because you could be smiling, but maybe it's more of a grimace, and that's, that could be not necessarily that quote unquote happy emotion you're looking for, but
the
it is
true
still
smile.
right. But it's still considered a positive variance, and which is why the zygomatic major should be done in conjunction with the OO, the orbicularis oculi.
Yes, and we call it the OO because it's easier to say.
Yeah, there's so many tongue twisters. So that information from OO is actually located on the outer eye corner, and that is frequently utilized to help determine eye blink responses. So if something is surprising, say maybe a fire alarm goes off, or there's a door slam, and it actually increases activity in that area because you're responding to that surprise. And so
these measures don't have to just be used for the positive and negative. The OO can also be used to check for eye blinks when you're doing EEG, for example, which can cause a lot of noise in the system. The zygomatic can also be used to look at chewing effort, for example. Right. So there's other things you can use these measures for. But predominantly, we use it to look at the positive and negative emotional experience that someone might be having, say, looking at an ad, or smelling a fragrance, or looking at a pack, whatever it might be. All right, so the last one, the third one, is got a lot of names here.
What do you want to call it today?
Well, I often say GSR. A lot of people say EDA or CSR, I think, are the most popular. GSR being galvanic skin response, EDA, drawing a blank.
So EDA is the electrodermal activity.
Right, electrodermal activity. Basically you're looking at sweat on the palm of the hands, right? Yeah. So you're looking at how much electrical activity is being transferred through the skin.
Right.
And conductance, or SCR, which is also one of the names.
Exactly. And if we want to break down a little bit more, it's really caused by if your sweat comes from the response, if you're emotionally aroused, and that causes the positive and negative ions to change, and that's what's creating the gland's conductivity to change, and that's really what we're looking at. So when we say arousal, it's really more of we're implying it's an overall activation, and that's done through those ions changing. So it's always kind of important to remember that when we're discussing it, because I know it can be misleading when we're using words that you might be confused about.
And also, this isn't actually measuring the sweat on your hands, it's measuring the conductance of the skin. And I think that's something important to bring up for all these measures that we've talked about, is that you don't have to see the person smile. Just the slightest amount of electrical activity can be recorded as whether or not it's a significant difference from baseline, right? Or a significant difference between two stimuli, right?
Yeah, exactly.
So making sure that, it is a real response. But you don't actually have to see the person's hand getting sweaty, and you don't have to see the person smile. The person doesn't have to feel that their heart rate has changed to be able to measure that.
Yep, your body is changing frequently all the time. So, and you're not always consciously aware of those changes. So that is a really great point to bring up. And in order to understand skin conductance more, it is broken down into both tonic skin conductance and phasic skin conductance. So really quickly, tonic skin conductance is changes over long periods of time. And those waveforms, because those are both waveforms, that tonic and phasic skin conductance, It varies based on, your state and your autonomic regulations. So it can kind of help to represent the noise, like maybe something like digestion or hydration, things along those lines. Whereas something like phasic is actually used to help determine faster changing waveforms. And that waveform response happens when, the sweat ducts fill as a response to what the person is experiencing. And they could be experiencing something, it doesn't have to be physical, it could be something that they're thinking about to create that type of a response. So, if you notice that your palms are sweaty before a first date, or you're about to walk into an interview, those are the phasic waveform responses. And they're generally shown as bursts and peaks, as you can see in this graph.
Yep. And we're looking again for those meaningful changes that might be significantly different, right?
Right, exactly. The one other thing I will bring up, which we can tie into this, it goes for either one, is that with something like GSR, you can change the configurations. It doesn't necessarily have to be on the palm. So if, like we mentioned before, if maybe you're doing research that includes the hands, we can place that in a different spot where it could be
you can use the
on
foot.
the wrist. Yeah. Right. Yeah, or even you have the possibility of your neck or your shoulders. So you can get this information. It's not only to one part of your body.
We typically just try to use the ones that are going to be the most reliable, right?
Exactly.
Or have the clearest sound. So putting it all together, when we're looking at facial EMG and GSR and heart rate, they actually all do fit together. So if facial EMG is giving you the emotional valence, or whether you're feeling more positive or negative, and then you look at GSR and it's giving you whether or not you're feeling more intense or aroused or more relaxed, right? And then you can talk about whether or not you're paying attention with the HRV, so whether the person is going towards something, approaching it, or avoiding it. Then you can start to map out how the person is feeling. So you can imagine if someone is feeling more pleasant and more aroused, then they're probably in that happier state, right? But then you can use the third dimension of approach withdrawal to see some more nuanced differences, right? So fear and anger are both arousing and unpleasant, but you can use that approach withdrawal, measure the heart rate, to really see that there's a difference between anger and fear, right? So when you're angry, you're approaching something, and when you're afraid, you're retreating from it. So we don't try to look at these only in silos, which we do for sure, to see that there's, changes in arousal, there's changes in heart rate, et cetera. But we try to look at the holistic picture of that experience, because it really tells you a little bit more about understanding that emotional experience, right?
Right. And I think we do mention that this particular approach is really useful in encompassing that whole consumer experience. It's not, it's all of these tools work best in conjunction with each other, because
it's not going to tell you enough to just know they're feeling positive or negative. You really need to know, are they focused on it? Are they feeling motivated towards it? Right?
Right, exactly. And we do actually have, in a previous vidcast, we go much more into depth about a visual that we frequently use with these tools, referring to mood maps. So if you're interested in that, please feel free to go back and check that vidcast out as well.
Yeah. But a lot of people get kind of worried about using these sort of physiological measures, because you do have to put gear on people, right?
Right.
But it's not that bad, right? And actually, Allison here, who's actually the model and has joined us on the vidcast in previous episodes, she is always the person who's the guinea pig, or not always, because actually Kathryn has been as well. But often the model, or the guinea pig we do these things on. And she's often forgotten she's wearing these. If you've ever been to the hospital and you had an EKG done, often they've left one of the electrodes on you and you don't even notice until you go to take a shower. So it is possible to forget that these things are on you. It's really not that intrusive. right? There's an acclimation period that we try to do to make sure the person feels comfortable before we start the measure, because again, you don't want to be having them in that heightened state where they know they've got all this gear on them. Maybe they're uncomfortable at first, but usually they settle right into it and they forget it's even there.
Exactly. And as a technician, it's part of the job to inform the participant exactly what they are, what they're signing up for, to make sure that there's consent with it. But also what's really important about the screeners, and it's often the job of the technician to ensure that there are no allergies, because really the only reaction you would have is if there's an unreported adhesive allergy that we weren't aware of.
Because there's nothing else being put on you, right?
Exactly. Yeah. So
but also you don't want to have people, so, considering screening people with those types of allergies, you want to make sure that they haven't had Botox recently, because then obviously their face is not going to move.
Mm-hmm. Right. And it's fun though when you're speaking with participants, because you do get questions where people are concerned that they're going to get electrocuted, and it's a fair concern, but no, you won't be electrocuted by any of these tools. Everything is really, really safe, and many of these labs are specifically designed so that it never connects a respondent to a building power. So you are safe. Yes, you are very safe in these measures, and the measures are really useful because it's portable. We can do this research anywhere, like we always share in the beginning of our vidcasts. And the artifact we can account for through the data, but also when we're collecting the information, the technician's in the room, and you can control for your surroundings to really know if a fire alarm went off. You will,
or a sneeze.
Or a sneeze. Yeah, it could be. I clearly I jumped to the biggest extreme, but it's something as small as a sneeze,
which is also going to have a large effect.
Exactly. So,
and that brings it back again, why this is the gold standard, because it is data that you can very clearly work with on a very, detailed level. You can clean it from things like someone sneezing or coughing. You can rely on it, that, it is very reliable, because you can, if heart rate is pretty standard, taking heart rate is very standard. But also, again, it is a direct measure of what it says it's measuring. Facial EMG directly measuring positive and negative valence. Skin conductance directly measuring arousal, and heart rate directly measuring attention. So it is a gold standard of use, and easiest to use. It's not as sexy as some of the other measures, right? Because a lot of times we have clients that are asking us to put gear on heads, right? And they need EEG or fMRI or FMIRS. But those honestly aren't always as reliable as using the gold standard, right?
And I would disagree. I think Allison has never looked better than in this photo.
You wouldn't be able to see her lovely hair if she had an EEG cap on.
Exactly.
See, this is a real test on whether or not she's listening.
Very true.
But all right, and with that, thank you everybody for joining us again. Please feel free to email directly to myself or Kathryn. Link with us on LinkedIn. Please like the video that you're watching, and leave a comment if you like, a question. Tweet with us. Visit our blog. We have lots of papers we'd love to share with you, including our own white papers and publications, or some of the articles that are out there that support the validation of any of these measures. So once again, thanks for joining us, and I hope you can join us next time on the HCD VidCast, where we will talk about yet another exciting topic.
Thank you, everyone. Take care and have a great day.